So this mic, right? Like I can just talk like that. Okay, wonderful. All right, let's get started. So welcome. My name is Dave Ormsby. I'm from Axiom Collaborative, and I'm going to be talking about modular content storage with Learning Core. So first, defining a few terms. So modular content here means things that are not courses. Libraries is getting a major relaunch that's going to happen in Sumac. And we're just going to start with containing things like components, videos, problems, and so forth. But eventually the idea is for it to hold other types of modular content as well, things like units and sections. Learning Core implements core content primitives to support the Sumac content libraries release, which is, Sumac is going to release at the end of the year, and supporting in an extensible plugin-friendly way, and hopefully do a bit more. And so now I'm going to try to kind of unpack this sentence line by line. So what is being built in Learning Core for Sumac? I mentioned core content primitives. The important thing to know here is that Learning Core is part of libraries, but they're not the same thing, or they're being built to support libraries. So some of the things we want to deliver in Sumac for libraries, first there's going to be an entirely revamped front end. Well, the libraries experience is going to look completely different. That's not Learning Core. There are going to be a bunch of things developed in edX platform, things around the libraries app itself, synchronizing library and course content, REST API, search. None of that is Learning Core. Learning Core is the thing on the bottom. It is the sort of very basic foundational building blocks that we would have for content. Things like asset storage, basic component, like storing component data, drafts, managing draft versions, published versions, the history, and so forth. So to give an example of what this divide looks like, this is a problem component. The code for this is in the problem block in edX platform. So edX platform and the xblock repo will have all the logic for how this problem behaves, how it renders to the user, how it interacts with the user. edX platform and xblock also have all the code that determine how this problem gets serialized into OLX, which is our XML format for storing this information. Learning Core will store things like the identifier lookup. This is how we'll derive the usage key, for those of you who are familiar with that. It's also going to determine how we store, it's going to provide the storage mechanism for the OLX, the serialized version of that problem, any images, associated PDFs, so forth. Learning Core doesn't understand the OLX, but it just knows how to store it. Learning Core is also going to manage the logic around draft and publish versions. Okay, so an obvious question might be, why not just reuse ModuleStore for all this? Because ModuleStore is what powers courses, it's what powers version 1 libraries, and don't we already have all this functionality? So to help explain this, we'll go a little bit into the evolution of ModuleStore. So the first ModuleStore was XML ModuleStore, and that was a quick and dirty hack that read entire courses into the files, from the file system into memory every time the LMS started up. And that is what you do when you have a prototype hack. At some point, we really needed to make Studio, and so the next ModuleStore is called Old Mongo. It wasn't called Old Mongo when we created it, clearly, but it got that name sometime in the 10 years we tried to deprecate it. But Old Mongo had some big problems. One of those problems was that imports were not atomic. Version changes weren't atomic. So we would have these unfortunate situations where an import failed halfway through and half the course is updated and half the course wasn't. And there was all kinds of craziness. And MongoDB didn't have transactions back then. So Split Mongo tried to address these problems. And along the way, also tried to optimize the data store for displaying the outline. So how does split module store work? So split module store works by basically you have these big documents that represent a snapshot of the version. It's going to have in that snapshot file, in that structure file, it's going to have the entire course tree or the set of contents of a library. And it's also going to store a bunch of metadata in that. Like, for instance, the display name. Anything in the settings scope for XBlock fields is stored in this one document that is shared across the entire course or library. And that document can grow very large. We've seen them up to 2 megabytes. Actually, I've seen them larger, but it actually just breaks after 2 megabytes. So we'll call that the limit. And then the snapshot has pointers to a bunch of definition documents where the actual text of problems in HTML are defined. The bad thing about this from a technical point of view is that in order to get data for one component, you not only read the small definition document for that one component, you have to read the giant version document as well. The same thing goes when you're writing, when you're doing a write. You have to write this snapshot for the new version, for every edit. So that leads us, basically this is where we're at. ModuleStore's fundamental design, that the split ModuleStore design, cannot support the product requirements for content libraries for a number of reasons. And so let's use this opportunity to build something better. So speaking of making it better, what does plugin friendly really mean? And for us, this means that Learning Core treats plugins as first-class peers to edX platform, right? Like, one of the problems that plugin maintainers face is that they have certain expectations, like they're relying on certain things to stay stable in the API. And in this world, edX platform can feel a little antagonistic because it's not really held to any standards in terms of keeping API stability. If you are writing a plugin and you're interacting with content today, you're basically blindly importing stuff from edX platform and hoping it doesn't break. Or maybe you have a clever shim layer that you've been forced to create in order to make sure that you have a little more stability between releases. But edX platform doesn't make you any guarantees. What we would prefer to have is plugins as peers to edX platform. So edX platform will be using Learning Core, but it will be using it in the exact same way that any plugin will be allowed to use Learning Core. We already sort of have a model of this with OpenEdX events, where we have both edX platform and plugins can use events, have requirements that set events have better better stability guarantees. Oh yeah, and actual documentation, that's also a goal. All right, so what are we building? Why are we building it that way? And why should you be excited? Okay, so before we start this, I just wanted to say that I realize everything I'm going to say in the next few minutes is going to make it sound like I only discovered relational databases 3 months ago. And people who haven't done much OpenEdX development or not this particular part of OpenEdX development might honestly be surprised that these models don't already exist. But that is a byproduct of the sort of evolution of this code base from where it started with that XML ModuleStore all the way until now. And so in many cases, we're retrofitting a model into, like a data model into what already exists. So one of the first product requirements is that libraries need to scale up to be very large, up to 100,000 items. These items are going to start with components, like videos, problems, but eventually it will hold other things as well. So ModuleStore limitation here is you can't really support more than about 5,000 items in a library or a course before the entire thing breaks down. In fact, it starts to really break down earlier than that, but it just depends on the size of your items. So of course, this brings us to the obvious solution to this is to have granular versioning. Right, so here we have the components app. It's an app in Learning Core. And you have a component and you have component version. So there's no more big, slow version snapshots. So we have transactions now. It's a thing. It's great. It also means that we have much faster access to individual components because in the past for ModuleStore operations, you're doing about 1,000 times the data access, read and write that you actually need to, or that you should be doing. And it introduces a real data model for foreign key relations. So you're not using a bunch of usage keys as string fields in your database. The other part of it is that we want granular extensible versioning. So I showed you component and component version, but that's not really our system, Learning Core doesn't really publish components and component versions. There is a separate publishing app which has an abstract notion of this is a publishable entity and these are versions of that entity. And components uses some mixins to have one-to-one relationships with the publishing entities and versions. And so the idea behind this is that in the components app, attached to the component version model is all the stuff, all the extra models you need to define what a version of a component actually means, the OLX, any metadata you want. But the actual logic of is this a draft version? If this is the draft version, this is the published version. That all happens in the publishing app. So when we actually create, units, sometime for Teak probably, it will do the same thing. Like units will be publishable entities, unit versions will be publishable entity versions. But that also means that if you're writing a plugin and you want to create a lesson plan and you have versions of that lesson plan, you should be able to use it in the same way. You have to still define what a lesson plan means and what data is associated with it, but the publishing app should be able to just say these are the draft versions, these are the published versions. We also are going to have explicit models for the draft and published versions. So every publishable entity has one draft and one published version at any given time. This means we have fast queries for here are the current drafts, here are the current published versions, here are unpublished changes. The one thing that we lose is we don't have as easy an ability to roll back to a previous snapshot that we did. We can still go back to a point in history, but it's a little more complex. Another product requirement is to have many concurrent authors. And ModuleStore limitations hit us in a bunch of ways there, right? So it's difficult to know who else is working on what. And one of the reasons, and that's difficult because it's expensive to query changes between versions because you have those giant documents. And concurrent edits to libraries and courses can cause data loss. Okay, I don't want to freak anyone out, but the reason why this can happen, and this can happen in particularly in very large courses with active teams working on them, is that, again, every write creates this giant version document, and that's slow. So if you have two people who decide to save a change at the exact same time, those are going to generate two separate documents, one with one person's change, one with another. And these can be entirely different problems that they're working on. And one of those is going to win, one of those is going to write and be promptly forgotten and dropped on the floor. Again, doesn't happen often, but it has happened, and it sucks when it does. So the way we get around this issue is to create an explicit publish log. So I've already covered publishable entity, the entity version, and the published model here keeps track of what is the currently published version of what's currently live. So there's another model called publish log, and that's going to have a new row every time someone publishes. Whether they publish one thing or whether they publish 30 components at the same time, there's one entry here. Now, of course, that entry is going to have a foreign key to user, so you can see who did the publishing. It's also going to have a record, a publish log record. That record is going to have one entry for every thing that was published, for every component that was published or unit or whatever. So one of the nice things here is that whenever you look at what is currently published, you will also be able to immediately see when it was published, what was the thing that published it. The record also holds what was the previous version of this thing before the publish. Well, and what is the current live version after the publish has happened. So what are some plugin implications for this? So a lot of plugins take some sort of action when a publish happens. A lot of things take actions when publish happens. But how do we know what happened to them? Sometimes celery tasks just die. Things are incomplete, and we don't actually know whether the updated data in your particular application was from yesterday's publish or from today's. So that brings up the topic, like what kinds of data would any authors like to attach to these publishes? You can imagine, if you have some artifact that you're generating based on a publish, yeah, make it a one-to-one model with the publish log, and then add your particular data for whatever successful task you made. And the nice thing about Django introspection is that we'll actually be able to see what all the models hanging off of publish log are. So it'll give an ability for us to determine, from the system's point of view, what are all the plugins that are supposed to have a row entry for this, but haven't reported in yet. So another part of the requirement is that assets must be versioned together with components. So diagrams and problems, subtitles with videos, photos for test components. ModuleStore doesn't do this. There are no assets in ModuleStore libraries at all. And assets and courses are separate, and they're not versioned. So you have all this draft publish semantics around like an HTML block, but then you change the image that it references, and that's immediately live. Also, serving non-public assets scales poorly, which I'll talk more about in a bit. All right, so here, this is going to look probably a little bit funny, but asset and text storage both happens using the same table in the Contents app in Learning Core. So there's a model called content. It's going to have a hash digest of the content to uniquely identify it. It has an inline text field where you can store text information like OLX. And it has a separate indicator to say whether or not there is a backing file. Regardless of whether it's text or it's file-based, it will have a media type. So for an image or something, for a file, it could look like the top one. That really long MIME type is the vendor recommendation. So that's going to be every Xblocks OLX will have a MIME type that looks something like that. And finally, it's going to have a file store backend. Django storage is backed, so either S3 or like a file system. So it does text and file-based backends. So what are the trade-offs here? Inline text will give you really low and consistent latency. It's just another thing in MySQL. You'll get like 1 millisecond latency, very predictable. Latency for file-based stuff can be much higher and much less predictable, particularly if you're using a service like S3. Inline text is intentionally not downloadable directly by the user. File storage will be. Inline text is only for small things. File storage is obviously very large. Think files and uploads. And relatively speaking, anytime you store stuff directly in the database, it's more expensive than storing on the file server. And it's also possible to use both at the same time. Although I'm not clear that there are use cases for this, the data model supports it. So now we can bring it all together. The contents are really dumb. Content is just a blob of data. The Components app bridges together contents and components with component version content. Basically, for each row in this particular model, it tells you what the identifier for it as a file path, what component version it's a part of, and what content that points to. So here it says, for this particular component version, block.xml is pointing to this piece of content that is OLX text. This component version also has a diagram image file, and that's going to be some file-based piece of content. So why a file system analogy? Like, it makes import and export really easy in map. It makes it easier to support XBlocks with associated assets. In the long term, we do want to support components that are not XBlocks. This is kind of aspirational, and there's no immediate items on there, but it's a door we want to leave open. And we want to make it easier to author non-XML XBlock content. So what I mean by that is, all right, so if you folks have ever written Python code in a custom response Python, like a problem block, a problem, you do something like this. You have a bunch of Python code. You have to XML escape your Python code, which is crazy. But you shouldn't have to, right? Like, you should be able to say, hey, here's a script, and point that script to the greater.py file that's in my, that's associated with this problem block, and just have it read that. All right. And that also, another pain point is the permissioning system for static files. Okay, and waving my hands, this is not going to be available in Sumac. Like, we're going to build infrastructure on the content library side that can help with this in Sumac, but this won't be coming to the LMS for until a little while afterwards. So Studio currently supports public assets, meaning anyone in the world can read it, and locked assets, meaning that everyone who is enrolled in the course can read it. But there are no restrictions beyond that. So the new mode we want to enable is basically anyone who can view this component can read the asset associated with the component. That means that you can tie assets to release dates, to enrollment tracks, to cohorts, to milestones and prereqs. All the things that you would that affect visibility for XBlocks would do the same for static assets associated with those. Now, there's a scaling challenge here because Python Django is really bad at serving large static files. So, one of the ways we could have done this, is the way that static content server more or less works today, which is you get a request for an image comes in, and you have Caddy or Nginx as your proxy front end, and you have Django serving on the back end. And then we could look up in the learning core in the database to see, okay, for this static asset associated with this version of this component, what are the actual file bytes that I need to care about? What's the content I need to care about? And Django could send that image data back to the server, back to the user. But this is slow. We get away with this on public assets because there's a CDN sitting in front of it, and it can be very aggressively cached. So even though Django is really bad at this, it doesn't have to do it very often. If we are tying them to component permissions, then we have to serve them every time. Fortunately, there is this magical header called XXL redirect, which Caddy and Nginx both support. And the way that this works is when the user sends a request, still goes through Caddy, still goes through Django, we look up the entry in the database for what content we care about. But instead of having Django serve that image data directly, our web app just sends XXL redirect header that points to a location that Caddy or Nginx can access. And then Caddy or Nginx does the work of actually serving the file to the end user. And this is way, way better. Like orders of magnitude, at least one order of magnitude better in terms of serving, and 1 to 2 orders of magnitude better in terms of memory usage. So we really want to use this. And it's possible that this is good enough to actually serve video straight out system. I put a question mark there because I haven't tested this yet, but it does seem like a sort of logical place we want to go with this, instead of having the video files be completely separate on a different system. So an architectural requirement is that content metadata should also be extensible and queryable. So we want to quickly find things like information like dates, scoring data, allow plugins to build rich data models, manage the whole plugin lifecycle, which I'll talk about more. And there are limitations. ModuleStore has limitations here as well. So there's no way to directly reference or extend content. Like you can't make a foreign key to anything in ModuleStore. And XBlock removal can actually make content inaccessible. And also, another aspect of like not being able to directly reference is that a lot of times for any particular piece of information you want, you're instantiating an XBlock, doing all the like crazy computational work for that, and then asking for attributes on that XBlock, when really you should be able to find it in some indexed field somewhere. So for this, we have a sort of notion of progressive data model enhancement, right? The content is a dumb blob of data somewhere. But if you have an image, you can create and you care about images, you can create an image content that links to it and extracts out the information that you care about. Same with text, subtitle tracks, right? You can extract out things like language and duration, and you can put that information in a separate model with indexes. For component versions, we can extract out the score information. How much is something is a component worth? Like, what is the max score? What is the weighted score? That doesn't have to be something that hangs on the XBlock. That's information that we can push into a model here when we do the writing. And similarly, if you have an XBlock that has a rich data model that you want to be able to query, you can add that. You can supplement the OLX in your system that's stored for your XBlock's data with whatever like nice data models you want to hang off of that data. But then you might ask, why store OLX at all? Because I just talked about how we can store nice structured data for your XBlocks. Like why even bother with OLX? And because ModuleStore doesn't. ModuleStore does not store OLX in your system in the back end. And to explain this, I'm going to run through what ModuleStore import looks like. So ModuleStore import looks like this, where you start with some OLX, and based on the tag, which is cool assessment here, we figure out what XBlock that this OLX maps to. And then the XBlock parses that OLX, and it turns it into XBlock field data. And then our runtime knows how to save that field data into MongoDB. When you export, it works exactly in reverse. You take that MongoDB documents, you convert it into field data, find the XBlock that's responsible for it, and have the XBlock spit out OLX again, so we can serialize it for export. Okay, the problem, I don't know how many people have run into this, but the problem is that content lives longer than code. At some point, cool assessment block gets deprecated because no one wants to maintain it, and then it gets removed. And then you're trying to export, and there's literally no way to get that data back out of your system. So for whatever plugins you have, it will be strongly encouraged to build whatever useful data model off of the OLX. But at the end of the day, when your plugin goes away, for whatever reason, we still want to be able to export that data. Another operational requirement is to reduce cost and overhead. ModuleStore, of course, requires MongoDB to work. It is one of only 2 things that require MongoDB, and the other one will hopefully go away in sometime the next 2 releases. Also, referencing content from MySQL, when we're talking about usage keys and so forth, we need varchar fields and indexes, and those are huge. A site like edX wastes terabytes of space in their database on indexes for usage key fields and course key fields. So Learning Core, does not use MongoDB, and you can use big integer fields instead for indexes. Okay, so what's after Sumac for Learning Core? So some of the things we're looking at are container types and libraries, for instance, units. And also on the technical end, what it would take to actually model courses with this as the underlying backend and what that migration would look like. Also, what it would take to compose a unit for a student. And what else can we do with library content? It seems, honestly, it seems a shame to be storing all this cool modular content and then have to use it in courses for everything. So I think that would be a really fun thing to dive into. Okay, so now I'm going into possibly slightly more controversial territory. How does this fit into the bigger picture of things and where we're going with architecture and OpenEdX? I want to make it clear that these are assumptions I want to challenge. What I am telling you now is does not mean a change in policy or doctrine. There is no OEP or ADR for this conversation at this time, but this is a conversation I will want to have in the near future. So assumption number one I want to challenge is that edX platform repo should be our core. So I feel like this is something that has kind of been implicit in a lot of conversations over the years. This idea that we should move everything out of edX platform because if we shave away at it long enough, we'll be left with a shiny core, and that represents like the essential parts of our platform. I don't think that will ever happen. This is a line count of Python code in edX platform over time. And you see it's growing way slower than it used to. The DEPR working group has done wonders. People have done their best to move development into other repos, but that line is not going down. And part of why it's not going down is because the actual benefits of extracting features out of edX platform, like if we're talking about that small core that we're aiming for, it's really backloaded in that there's a whole lot of effort to bring down the lines of code. And really, like that small understandable core is at the end of that. And that's like, impossible to get support for. You can't say, oh, I'm going to go and spend the next 5 years doing this instead of building features, and at the end there'll be something shiny. I think the other problem is that dependencies make feature extraction like really difficult. Even things that you don't think would have dependencies. One of the worst things we ever did to a new hire at edX, and I still feel bad about this to this day, is like, hi, welcome to edX. This is the OpenEdX platform. For your first assignment, we would like you to extract ModuleStore out of edX platform into its own repo. We did that to Brian Mesick. It's a miracle he's still with us. I still feel bad about that. It's hard, and it has all kinds of dependencies that you wouldn't even expect. But the real goal isn't to the real goal is not to make edX platform smaller. Right? That's a means to an end. The end goal is to make the overall system simpler to interact with, extend, and maintain. And I think that the viable path towards that is to extract out the simplest low-level concepts that plugins need the most, and build on those so that each thing that we add adds value for those developers. And also to try to cutting this swath where there are fewer dependencies because we're already starting at kind of the lowest layer of the dependency tree. Even more controversial, assumption number two that I want to challenge is that we should strive for a single core. And I feel like in our language, we use the word core a lot and for many different things. But I think there are at least a few core domains, and this is very incomplete, but events, for instance, is something that can stand almost entirely on its own. If you have any random Python thing that sits on the message bus and is interested in things that happen in an OpenEdX instance, you can use this one repo and you can do like whatever integration work you need to do. I think there's actually a place for a major repo that does provisioning, like roles, permissions, enrollments, things an SIS would care about. And this is something that almost every OpenEdX service would use. And one of the reasons for this is that, like right now, we propagate this information in a kind of hacky way, right? You use JOT tokens, and when you go into another service with that JOT token, we auto update your user information, role information based on the value in the JOT. But if you provision something, you make someone a certain role that is relevant to another service, and they don't log in, like that never percolates, or it can through other hacky mechanisms. But in any case, I think that there's a good argument to have some centralized repo for those concerns. And then I would like to see Learning Core grow into to encompass more the teaching and learning experience. Still, it's not going to replace edX platform, right? But to encompass more, right now, everything that's being done is being done on the authoring side. But there are a lot of low primitives that also make sense, I think, to pull in. Things like user partitioning, the logic of how we determine what content a particular student sees. All right, and I just wanted to recognize that Learning Core is brought to you by Braden and from OpenCraft and Kyle, my colleague at Axum. They have been my partners in crime for all the architectural discussions and as well as a lot of the coding and review. Also, Jenna for her incredible patience in answering all our inane existential questions like, what really is a component? Which happens way more often than you would think. But yeah, no, it's been fantastic working with all of you. And yeah, so that's it. Thank you, and any questions? Felipe.
Yes, that looks fantastic, and you're mentioning this will replace. Thanks. So that looks fantastic, and you're mentioning this will replace the libraries for Sumac, right?
Yes.
How do you envision this replacing Mongo, ModuleStore completely, and becoming the central place where all the content is stored, like course content as well?
Yeah. That is honestly needs a lot more discovery work around it. Right now, we've got this thing where there's a lot of, as far as the LMS is concerned, right? A lot of the structural queries around course outlines and stuff are already not hitting XBlocks directly. They're sort of in these sort of compiled structures that happen after the publish process. I'm not sure exactly where it's going to fit in, but it's going to be the plan would be to be some incremental process to gradually bring things over. I don't expect it's not going to be like the old Mongo to new where IDs change or anything. We still want the exact same courses to appear to the user like they're working the same. But yeah, I don't know. There are a lot of moving pieces of that, and I'm happy to talk about it in detail. But basically, there are at least a half a dozen things that we need to get through around files and uploads, figuring out the composition of units and so forth that we have to go step by step. Braden.
Felipe kind of asked the same question I was going to ask, so I'm going to change my question and ask, how do you think about what goes into Learning Core or not in the future? Would grading go in? How would you approach that question?
So I think that it starts from the lowest pieces, and it would make sense to put in higher level pieces as those pieces become, how should I say, depending on how useful those would be to develop plugins for it, right? For plugin interaction. Because ideally, we want plugins to be able to get as much access to the functionality they need in edX platform without actually calling into edX platform. So, for instance, if we're talking about grading, I think the first thing that would go in is actually scoring, like like the logic of like this is how many points is for this particular thing, this is how much a student has scored for this particular thing, and then one layer, like maybe after that's been out there for a while, then like we would consider like is actual grading policy something that would go in there. I don't know at this point. Oh, Freddie.
What happened to BlockStore?
Ah, okay. So BlockStore. So for those who are not familiar, BlockStore was an initiative around 2018, which had very similar goals in terms of making a new libraries experience. So there are a few aspects of that. I actually really considered putting BlockStore into my slides, but I think there are like maybe 6 people in the community who actually know what how BlockStore works. So I thought I'm confused more than anything else. But to answer that question, one, there is a lot of BlockStore code that still remains. So the XBlock runtime code that works with content libraries is largely renaming BlockStore XBlock runtime to Learning Core XBlock runtime. There are other things developed during BlockStore like making the course keys more generalized to be sort of learning context keys. So those things are still in platform. The sort of lowest level like storage area, the part that most overlaps with Learning Core, that repo was deprecated and removed. And if you look at the design of that repo, it's kind of like an in-between, it's like a kind of an in-between state. So we took a lot of things from that, like the association of files with XBlocks, the sort of the general file-based nature. Also, a lot of the things that we did around the content data model, particularly around content, like how we have the hybrid storage, we did that explicitly because we learned operational lessons when LabXchange was running BlockStore, as well as the static asset handling. So yeah, so I guess the answer is that development effort. How should I say? We never fully completed and launched the libraries that on top of BlockStore platform. A lot of that code survives in edX platform, and a lot of the underlying code for the storage model is different now, but it derives directly from like lessons we learned while working on it.
One more thing there. Can you go back to your first assumption?
First assumption. All right.
Yeah, I found this a bit confusing. So when you say the edX platform should be our core,
Mm-hmm.
and then on the next slide you say the core is going to be too big. We
Mm-hmm.
can't do anything about it. I find that a bit contradictory.
Oh, I see. So the assumption that I want to challenge and say is wrong is that edX platform should be our core. So I think that basically I think that we in the past we have talked about edX platform eventually like shrinking down, and I'm saying that I don't think that will ever happen, and I think that the more useful like goal to pursue is to basically create a new core by extracting out the lowest level pieces of edX platform.
But those two are sort of similar goals. So if
I'm sorry, I can't hear you very well.
Oh, that's fine. That's fine. Sorry. I find those goals similar. So if you want to make the platform smaller, that means you want to extract the code that is there and make them as a plugin.
Mm-hmm.
So if you wanted to reconstruct the platform with all the plugins with the same functionality, you can do that, but
Mm-hmm.
the plugins should not be depend on each other when it's not unnecessary. Right? So you're saying that we can do this because we have dependencies that are there when they shouldn't be. Then you say that shouldn't be the goal. So I think the goal should be to make it clean so there is no dependency where dependencies are not necessary. There's still a goal to go after, do you think? Oh, I can yell. And then you're gonna. Yeah. Your assumption is the edX platform is complicated. the code, the code is there right now, the function is there right now, has dependency on each other, the components have dependencies. To remove those dependencies is very hard. So for that reason, we shouldn't pursue that goal. That's sort of what you're saying, right?
I don't think. So I'm not saying that we like shouldn't try at all. I think that there are some things, like I don't want this to come. Oh my goodness, Ed would. So many people would kill me if you folks came away from this talk with the notion that okay, like edX platform is now the place you dump any and everything. Please don't walk away with that assumption. So I do think that we still need to like pull things out of edX platform that, you know, for instance, have nothing to do with the teaching and learning experience. Like there's still things that I don't think should be there. But what I'm saying is that I think that if we want to get to a core that is really useful, that you know, is very useful for plugin developers or for like being able to get features out without having to like wrestle with a very large crazy code base, I think that it is a faster path to getting there, a more viable path, is to do like the piecewise extraction so that, you know, edX platform largely remains, but you don't have to interact with it as much.
Yeah, the last one. Yeah. The only comment I have is where you say pull out is what I sort of, you and I disagree a little bit. Pulling, whether it's in the same repository or not, it doesn't really matter. But can you pull it out cleanly, which is what matters, right? Can the code coexist in the platform, but in a way that does not depend on things that it shouldn't depend? That's, I think, a goal that we still should pursue. Otherwise, the edX become, you know, a mess that you can't deal. If it's hard to deal with it now, and the graph that you show is the number of lines of code is going to increase, it's going to get way more difficult later.
Yeah, I wanted to clarify one super important thing, which you kind of alluded to, but I just want to make sure that it's crystal clear for everyone. So you're saying that in Sumac, so in October, edX platform will no longer depend on MongoDB, right?
No.
Okay.
Okay. Oh my goodness, that's a scary declaration. Yeah, so the long-term goal is to get rid of MongoDB as a dependency. That will not happen. Like, Learning Core will not be powering courses for at least a few more releases. So, you know, we're going to not use it for content library. So the idea is that the new content libraries will not use MongoDB. Old content libraries, which will still be around for a little while, will still use MongoDB. Courses will still use MongoDB. And so it's going to be a migration path to get off of it. I should get back out there, I guess. Thank you.
So, unrelated, about plugins, what is the API going to be? Is it going to be like a Python API? Is it going to be based on events? Is it going to be Django signals, MySQL API?
Most of it's going to be a Python API. And actually, one of the things we're trying to do different with Learning Core is instead of having a bunch of apps that declare their own APIs, like we actually have a bunch of apps with their own API.py files internally. But the interface that we want plugins and edX platform to use is actually like, there's a top level OpenEdX learning.api like authoring, for instance. And that package like aggregates a lot of things from various apps for those things that we want to make public, so that Learning Core apps can still call not quite supported in public things internally when they're talking to each other, but externally what they're exposing to edX platform or to plugins is in this separate module. And one of the goals of that is to be able to have better like deprecation of it. Like we can like easier to like make backwards compatibility shims, and you know, to for us to also be able to have some things that cross app boundaries, but not commit to long-term support for those APIs until they're more baked. I'm sorry, what? Sorry. I'm sorry. I've kept you too long. I'm sorry. Take care. Happy to talk about this at any time.